So for successful DFMA, need continuous research and system development. Those are key elements. Adopting new technologies and incorporate. Oh, sorry about that. The videos. Okay, second system is smart node system. As name, we name it smart nodes. So this is a state-of-art system that is opening new horizon for our designer. Anybody here architect? Oh man. All right, great. All right, I give you the freedom. Okay, you can design anything, any structural or form. All right, using 3D printing and steel casting technologies, any complex and bulky connection can be transformed to compact and elegant seamless connections. Oh, sorry, this video doesn't. Can you help me out how to run? Okay, so for smart node system, we have a 3D machinery. This is the 3D molding printing by using sand binding jet. Anybody have been seen these machines? This is 3D printing, nothing actually different. It's they using 3D sand and binder. So they just play the layer by layer, create the 3D printing, some molding. Second, yeah, we all know, right? Steel casting. Just burn and make a liquid steel and pour and make any form you want, right? So here, the image you see that this is we call smart node system. Yeah, it looks very quite easy, nothing totally new. Each module typically assembled on the side, nodes and branches, and members are temporarily OT connected and permanently welded, depending on the final finish requirements. All right, here is our current and recent project. I'd like to just celebrate with you. One is Gangnam Church. I'm sure you guys know Gangnam. Gangnam style? Okay. My son, when he was 5 years old, swimming pool party, everybody jumping and jumping, singing a Gangnam style. So that's the Gangnam. Second one is Galleria. The building was designed by OMA. Third, the Busan Opera House. Everybody love music, classical music? Yes, that's a world-class opera house under construction. So first one is Gangnam Church. Yeah, we completely designed assist service for cross tower. During the design assist, we focus on optimizing geometry for cost-effective and easy fabrication with curvature, material, and easy structural form study. We open create digital markup to find the solution and validate proposal system. And then we provide drawing and specification. Anybody here structural engineer here? Or anybody love parametric computation design? Woohoo! Must be young generation, right? So yeah, first step, we do structural form optimizations. It's a great word, optimization, with a parametric design tool. Rhino and Grasshopper, sound familiar? Rhino? Yes. Yes, and structurally, yes, structural finite element software step. We study most optimal number of nodes and die-grid patterns to find out most optimal, optimum structural and integrated facade solution. Oh, back to video. Yeah, now more and more digital technologies, we need to also educate our young generations, but you see the graphical challenge optimization need to somehow implement it through running Grasshopper parametric tools and communicate with structural software back and forth. That is how we have to educate our future generation. We need to celebrate our more lifetime. I think we don't want to recreate the 3D geometry and study every single, solution, right? Option. here. So next step, after we conclude the structural form, we to optimize the structural form and size, we study distance verification method using CATIA and validate manufacturing solution and provide cost estimate. Here is just one of the example design assist product, 2D dimensional drawing, but with 3D elements, right? Now project is in bidding phase. The groundbreaking will take place at the end of 2003. So we're gonna celebrate another Gangnam style with this. All right, second project, Galleria. So Korean people always use a nice name. This is department store designed by OMA architect. I call personally jewel box facade, right? It's a jewel box. The surface of a jewel box is 46,000 square feet, and facade system adapted smart node and steel curtain wall system. Total 647 smart nodes were used and completed in 2002. I will celebrate with you for this and a jewel box at the last video. All right, here you see we see that difficulties. Complex city. Oh yes, it's very complex. Looking, it's total based upon all number count. 34% of all the members are really bad and hard to fabricate. We need to rationalize and simplify and optimize, and so that is most challenging procedure we've been undertaken. Yeah, jewel box is very complex and unique and hard. Total 635 nodes. Very extremely difficult in geometric conditions, and fortunately, we developed a smart node system which make this happen and elegant than the system. Yes, during the design phase, we study each node also using finite element structural analysis and manufacturing method using 3D printing and steel casting method. So yeah, we also perform structural analysis in macro scale, micro scale. Yes, to confirm the structural strength and integrity as well. Okay, every side and corners, inside and outside, is full of beauty, right? Do you have a wife? Don't bring your wife to this jewel box. Unless you have enough money, all right? Let's enjoy a little bit. All right, third project, Busan Opera House. This is under construction. Ooh, this opera house. It's a world-class premium opera house, equivalent to Sydney Opera House. South Korea has a vision. Second largest city, Busan. Okay, to beat Sydney Opera House with Busan Opera House, right? The shape overall, we call that clam embracing the pearl. It's an ocean-fronted building as big as 150 meter by 150 meter, which is equivalent to, let's say, 400 by 400, even more. It's huge. Has a challenging facade covered by glazing and UHPC panel. All 10 of the facades are concave, and total we estimate 2,400 smart nodes will be used. So when it completed, this one is going to be the most beautiful, biggest opera house in the world. Okay, here's a little bit breakdown for facade system. Yeah, front of house, back of house, and cave zones. Yeah, those are, I think, divided into curtain wall and die-grid patterns, and some main screen with grid pattern, depends on geometry. Also, it's divided by some glazing and UHPC. Centerpiece of FOH and BOH wall highlight high elegant diagonal grid, concave form, reflecting historic and philosophical Korean culture. Okay, here's another structural backup. If anybody's, okay, I see the structural engineer over there. They will love to see this finite element method analysis, right? So they did a large scale full mock-up test for structural strength and integrity check. See that? The images is really pretty big scale. For architecture side, yeah, we also build some test mock-up to validate manufacturing method, right? Every corner geometry is changing. Nodes has a different angle. Installation sequence and overall quality for structural, architectural, air tightness, waterproofing, interior finishes. So we create the mock-up and try to validate and confirm the overall procedures. So here's the MA. Hope everybody now remember design for manufacturing and assembly, right? So complexity again can be redefined by simplicity. DFMA, Integral Design and Manufacturing Assembly Procedures. Key to successful DFMA, we need three key elements. The first, geometry optimizations. And we need to understand material and structural form as well. Also, we have to implement it, bring all the technologies. So you need strong backup. Manufacturing infrastructure should be near. So bring all technology, 3D printings, 3D scanning, robotics. Yes, everything is available. Now, yes, site, quality control is next. So all these platforms should be integrated. We need to practice. Yeah, at the end of the day, we don't want to just, we could go back home, enjoy most rest of the day with your kids. So, with that, I'd like to celebrate feature of department store Gwangju Galleria. Let's take a minute and take a look at it. We know how to celebrate ourselves. Yes.